So this is essentially what my agenda is. Hopefully that meets with what your expectations are on what we're going to talk about. So 4 major parts. We'll do an introduction, and I'll try to get to know a little bit more about your needs as well, so that I can tailor the talk a little bit more towards what sort of things you're concerned about. Then I'll talk about what the best coding practices for secure coding are in Java. I'm not going to be showing code. I'm not going to be going into this is the right way to do it, this is the wrong way to do it, because number one, I'm not a Java developer. I'm a security expert. I look for problems in code, and I let the people who have the know-how fix them and figure out what the best way to do it is. And it's not a one-size-fits-all. There's no such thing. Then we'll talk about secure development practices in general, because just because you code securely doesn't mean you have a secure product. So we'll talk about what it is you can do in your companies to look at what your processes are in the development space to try and improve them so that when the product goes out, it's more secure. And then we'll summarize it all. So who's Attachmate? I've heard people say, I've heard the name before, but I don't know what you guys do. We're actually a conglomeration between, or a merger between the old WRQ and the old Attachmate Corporation that was over in Victoria. WRQ was over here on West Lake Union. And both companies developed applications that allowed you to access different types of hosts. Mainframes, AS400s, OpenVMS systems, HP 3000s, I'm dating myself here,
Yes.
PDP-11s, LSIs, that, all the different types of systems out there that you need to be able to talk to. And that includes getting green screen shells on the systems, that includes SSH connections into things like Cisco routers, whatever you needed to connect to. And also, Attachmate goes one step further. It allows you to take information out of those old systems where most of the data is still sitting and present it in a new format, including web services. So those are the things that we're working on now, to be able to take that green screen and refresh it and put it up on a web interface and allow programmers to be able to develop. I need to get this information out of the account database. I need to get this information out of the payments database, merge them together in one window for my customer to look at. So those are the types of things that Attachmate does. And who am I? I've been in the software industry now for 30 years, the last 17 with Attachmate WRQ. I started out at WRQ 17 years ago as a software test engineer, working on the FTP client. We had a graphical FTP client that I tested. I moved on to working on the mail client, and then, of course, Microsoft decided to make IE and all of the things that go with it a commodity and put it on their systems, and pretty much that business went away. Fortunately, they didn't touch the host access portion of it. So, we've had a pretty good business out of it for the last 17 years. The last 3 of those years, I've been the manager of secure software development. I've actually worked in the security field all 17 years with WRQ. Worked on the SSH client, the SSL client, the Kerberos client, and interconnectivity between the different types of systems and the authentication methodologies that those systems use. So that's my bent. I'm not a developer. I did start my first programming language is Fortran 4, back on an old CDC 6400 at the UW, long time ago when we still used cards. And the biggest thing that ever happened was BT100 terminals came out, and now you can program and not have to sit there and rewrite the whole card because you made one typo in no time. Okay, that's my background. That's where I came from. Looking through the audience, it looks like there's a lot of you here that are probably could match a lot of that experience as well. So I'm glad to see that. Quick survey, just so that I know. How many are new to Java? How many just started programming Java? I didn't think there would be very many of you. About back to 1.6. 1.5, okay. Earlier versions, which is just about everybody else. That's pretty much what I figured, and that was the warning I got from Joanna, who recommended me to come and talk to you guys. So you guys have seen Java developing from the very first underpinnings when the first designs that came out to Java were talking about, here, we're going to virtualize everything. You're going to be in a sandbox. You're not going to have to worry about anything because we'll keep you safe. And we all know where that went. Okay? If anybody hasn't heard, Java 1.7 Update 21 was released today, and there's a new flavor of a redistributable. In addition to having the JRE and having the JDK, there's now the server JRE, which is essentially the server portion of the JDK without all the plugins, where all the vulnerabilities are. Right? Now you have, if you're doing server development or desktop development with Java, where you need a high-performance virtual machine that's more secure, you don't have to put on the whole JDK and worry about, oh, the plugins are there, and so somebody can get access to them. Okay, how many develop things like servers and servlets? Okay, large group. Desktop applications. There's a lot fewer of those. Web apps. Okay. Plugins, applets, the end user stuff, the stuff that goes on the end user's machine and is the most worrisome part of it, because that's what the user's touching, and that's what the user controls. How many of you have requirements to actually use JMI and get down to the native machine level? Okay, it's actually surprising. I would have thought that a larger majority would have. We do it in almost all of our apps. We have to get down to that level because we have SSH and SSL servers that actually have to be able to do authentication. And if you're doing system authentication, if you need to be able to authenticate a user onto a system, you need to actually have access to the JNI level because you can't do it otherwise. You can't do it well otherwise. Let's put it that way. Because you have to use the system's authentication methodology unless everything is hidden in the sandbox. That includes files and everything else. That makes it very difficult. Oh, by the way, my preference is if there is a question along the way, please stop me. If you don't, what will happen is we'll have a question and answer session at the very end, but you'll either forget to ask the question at the end, or you'll forget the context of the question, or I won't be able to understand the context. So please interrupt me at any time and let me know if you have a question. Okay, some facts about software vulnerabilities. This is stuff that has come out. A lot of these figures and data come out of the RSA convention that I attended a couple months ago. So it's fairly new data. The surprising thing is the percentages have changed a lot in the last few years. Okay, this has been happening for at least the last 5 years. Okay, it's nothing new. This also is nothing new. Number one on the OWASP top 10 list is SQL injection vulnerabilities. And they have been for at least 5 years. Okay? What's going on that we're not fixing these? Why are we not fixing it? It's not like we don't have a solution for these. We've known the solution for SQL vulnerabilities for almost as long as we've known about vulnerabilities. "75% of Microsoft security bulletins are for applications." Okay, Microsoft finally cleaned their shop up. I was on the dog pile when Microsoft first started touting security, going, "What do you guys know about security?" But they learned it the hard way because they had the big target painted on the back, and they kept getting hammered on that target. And they finally decided, okay, we're going to fix this up. We're not going to be doing this anymore. We're going to find a better way. Their operating system, Windows 7, is actually a lot more secure than any of the operating systems out there, other than a few that I'll show you that are really old, crusty, and nobody uses, or uses very rarely. 70% of successful attacks are through the application layer. Why is that? Well, the reason that the attacks are successful through the application layer is because that's what the attacker can get a hold of. That's what they can control. They get the application, they look at that application, they figure out what they can feed into that application to cause it to have problems. In most cases, they don't have access to the back end. But through an application vulnerability, they can get access into the back ends. And that's where they can do the damage.
What is some of the other 30%?
The 30%, some of them are things like the SSL vulnerabilities. So that's down at the network layer. There are actually protocol vulnerabilities that have been found in SSL. There are things like the recent problems with certificates, certificate authorities. Okay, that's not an application layer problem. That's actually a security policy and personnel problem where people are either issuing bad certificates to entities they shouldn't be, or they're losing their private keys, or letting their private keys out. So those account, those are some of the things that account for the other 30%.
So when you say application vulnerabilities, are these desktop applications or web applications, or
yes,
or all of them?
All of the above. Yeah. It's anything that runs at the application layer of the machine. This is the scariest part of it. Half of the application vulnerabilities out there are design flaws. They're not something you can fix with 3 lines of code or 1 line of code. They are actually badly designed apps that can never be secure. They have to be rewritten.
Perhaps an example would be useful here.
I'll see if I can come up with one in the Java space. I think I've got a lot more. Does it matter if it's Java for you? No. Okay. So one of the vulnerabilities, that we had in one of our products a while ago, and this was not a Java product. Okay. The vulnerability was in the way that the server was doing the authentication. Okay. We had understood that the server was supposed to authenticate us in a certain fashion, and we were supposed to provide it with a certain set of information, and it would come back with a yay or nay, you're valid or you're not valid. The problem was that what we found out was when we fed it a certain piece of information in the authentication packet itself, the server looked at that packet and said, I really don't know what to do with this, but I'm going to let you in anyway. Okay? That's a design flaw. Okay? As a stopgap, we're going to put this in. Design flaws will include things like Easter eggs and backdoors. Okay, that's a design flaw. You should never, ever release a piece of software that has a backdoor in it to your customers.
But still, while it is a design flaw, it could be fixed with a few lines of code. Certainly a backdoor could be fixed with a few lines of code.
Yes, a backdoor a backdoor could be fixed by removing lines of code. And it wouldn't take very many to remove to get it out there, yes. You're right there. But again, it's a design flaw in that the design of the product said, we have to have this backdoor because.
Wouldn't the design flaw be more like, a one-tier application where you got SQL sitting in the source of a web application that you're calling? You're obviously giving away the keys.
Right. Yeah. I mean, there's that. I mean, there are design flaws where the design is we're going to be openly communicating, and what we should be doing is we should have it encrypted. That's something that may be able to be changed with a few lines of code, but then it may not if the rest of your yeah.
There's I have seen not too long ago JavaScript that had SQL string concatenated in it. Someone else showed it to me. Luckily, it wasn't anything beyond found that would be a design flaw as your clients.
Right.
Writing your SQL.
Yeah, and we'll talk about those type of things.
I can think of another example too. In multiplayer games, sometimes the game will set it up so that secret information is sent to the client, even though like the player's not supposed to see it. For example, locations of other players on the map, and the design is based on the client hiding that information from the player.
Right. Yeah. Yeah. So that was a design decision that was made.
Right.
That we'll trust the client to be able to hide
Right.
things. And we'll talk about how these types of things how these types of things should be avoided. Okay. If you really want a secure operating system, buy Unisys. This, of course, I'll give this your full disclosure. This was created and looked at by Unisys themselves. Okay, so they're the ones that hired a consulting company to mine the National Vulnerability Database and look for all flaws that had to do with Unisys. Okay, and no, they did not find it. Yes.
It looks like it's proportional to the level of use.
Somewhat, yes, not completely.
Or market penetration.
Yeah. So, if that were true, I think Windows would be at the very bottom. You notice they're not. Okay, so not quite exactly true, but yes, it is. But these statistics that they brought in here go back about. I think they went back only about 10 years, if I'm not mistaken. I think that's as far as the National Vulnerability Database has data available. By the way, they got hacked, in case anybody hadn't seen that. They actually had somebody do a script injection on them, a malicious script. So when people went to look at this stuff with their servers, so lest you think that it can't happen to me. Okay, this is U.S. Okay. Where's Java fixing this?
Are we sure a Unisys hacker didn't get in there and hack the data?
I can't guarantee that, but I did make sure that I did do the search, the same search there, and look for Unisys, just the string Unisys, and I did only find the one report. So at least in that sense, it's consistent. Okay, I'll vouch for that. I didn't look at all of these other ones. I didn't have the time.
So it sounds like the answer to security is to write your own custom operating system from scratch.
If you want it to be secure, yes. And as a matter of fact, there are several efforts to do that right now. How successful they'll be, I don't know. The biggest problem that we have to realize, from a security versus usability standpoint is security is difficult to get usable. It's not impossible, but it is very difficult to get usable. So usually there's a trade-off between convenience. I want my user to be able to get in no matter what, and it's got to be secure. I got to make sure that I don't let someone in that shouldn't be in. Yes.
I believe everybody above HPUX actually tries for security, fancy security certification, do they not?
Well,
those guys are all sold for security, right?
No, Windows is too.
No, going back to the tail.
Yeah, but Windows touts their security, and in fact they do it now. They were the first. If anybody's heard of Common Criteria, anybody heard of that certification? They were the first to get Common Criteria certification, which essentially said this is the most secure system out there. Now, this was NT4. The stipulations, and this is the wonderful thing about these certifications. You as the vendor can stipulate how the system needs to be set up to be secure. So, Windows NT was secure. It was secure at about the middle level of security. They didn't go all the way up to the AEL level 6 or 7. They just stopped at 4. At the higher levels, you actually have to have tamper-proof chips and tamper-proof boards, so you can actually see if somebody's been tampering inside. Not just the box itself. You have to be able to tell if somebody's been modifying the chip on it. So they didn't go with that. But Windows NT 4 did get EAL level. I think they've got EAL level 2, not 4. They now have 4. But they got it with a stipulation that the box had to have just a monitor and a keyboard attached. Could not have any other peripherals. So no printer, no CD-ROM, no USB ports. Those had to be epoxied shut, by the way. No COM port. Okay? That stuff was all epoxied shut, so you couldn't use it. And it had to be in a locked room. And no network cable. No network board, no network cable. It was a secure system. Yeah, well, I mean, you could run Excel and Word on it all you wanted, but getting the data out to anybody else that you did in there was pretty much useless.
Photos of the screen.
Okay, where's Java in this? And I'm going to add Java as an operating system because I hate to say this, guys, it is an operating system. Whether you want to believe it or not, it's an operating system. Okay. As of, through 4/13, so the 10 years through 4/13 of last year, so a year ago, there were 752 vulnerabilities reported. Now, this is a quick and dirty. I don't know their methodology in getting all of the numbers here. What I did was I said, show me all of the vulnerabilities that have Java in them. And then I said, subtract out all the vulnerabilities that say JavaScript. Because as we all know, Java and JavaScript are not the same, but if you do a string search on Java, you'll find JavaScript. So that's pretty much all I did, was I subtracted out all the JavaScript ones from the Java ones, and we ended up with 752. By the way, don't have the figures with me, I think there were about 500 JavaScript vulnerabilities in that same database. Since that time, there have been 223 more reported. And today, they're reporting 42 more. So they're still Oracle is still on the upward trend as far as vulnerabilities go. They have not started leveling off. Okay. I think there's a parable that comes into this about building your house on unstable ground.
The total for Java makes me think that there's a problem with the other totals too, and that's, we're talking about a problem with my phone, a problem with the website, a problem with an application running in a browser. 3 different, totally different situations. And
Right.
the browser thing is that security model thing. But then a lot of that other stuff, a whole different problem.
Right. So the NPD does not distinguish. This chart does not distinguish between severity of the vulnerability. However, NPD, in one of the things that they have in the information you can get from them, is what is the severity. And they have a severity rating scale that's called CSSP, so Common Vulnerability Scoring System. And it goes from 10, which is an absolute takeover of the machine, to 0, which is, it really doesn't matter. Nobody can do anything with this bug. Okay, it's so difficult to find. So the CVSS scores are based on how difficult is it to find, how can it be exploited? Do I need to have local access to the machine? Can I only do it if I'm on the keyboard? Or can I do it from the network? Do I have to be inside the LAN or the WAN structure? Or can I do it from the other side of the world? Is this something that takes a rocket scientist to figure out and then to exploit, or is this something that a script kiddie can run? Okay, all of those types of things go into the CVSS score. The last time and I haven't looked at any of the 42 vulnerabilities yet today that Oracle announced. The last update that they had at 1.7 update 17, and don't ask me why they skipped 19, I'm not sure, I'm not clear on that. They're thinking on that. But when they released 1.7 update 17, they had 50 bugs, and I believe 35 of them were rated at the very highest level, complete machine takeover.
So you're saying that the bugs in this database have these level numbers associated with them?
Yes, for every bug that's in that database, they have the level associated with them, but these are not, I didn't look for just CVSS 10 bugs. These are all bugs that were reported.
Right, but it seems like it would be an important statistic to know whether those 3,000 Linux bugs are at, level 1 and the 2,000 Windows bugs are at level 10 or something.
Yes, yeah, I agree, and again, this is just to give you, I'm just trying to give you some context as far as the types of things are. I know on Java, from what I've been looking at for at least the last year, when Oracle announces Java bugs, 60 to 70% of the ones they announce are CVSS 10s. Okay. I don't know some of the older ones. I haven't looked, I haven't gone back that far to mine it. Microsoft, on the other hand, has reduced their level of CVSS 10 significantly, and particularly inside their operating system. Most of the operating system, or most of the vulnerabilities Microsoft is reporting now, are denial of service, which at the most will score you about a 4.5 to a 5 in the CVSS scale, because all it can do is just prevent you from doing this one thing.
Is one version of Java better than the other, or how does that rank?
I didn't look into it. My guess is you sort of you pay your money, you take your chances. I know people that are still running Windows 95 on their systems, and right now they're very secure. Nobody's going to bother to attack it. Yes, those systems are totally insecure, but for what they're doing, it's good enough for what they need. They're not going to, they're not going to be going out and surfing the internet. Number one, because those systems don't have the browsers, the modern browsers, to be able to do this with. And so the attacks, the attacks are happening on where's the money. Where it's no longer I just want most of the attacks. There's three types of attacks that are happening these days. One of them is criminal attacks, where they're there for theft. They're trying to steal databases of passwords to be able to sell, okay? Or credit card numbers, or social security numbers. That's pure theft, okay? That's one type of attack. And it's probably, right now, I think it's about, of the three attacks, they're all about a third. So you got to protect against them all, because they're all about equal as far as what happens. Second type of attack is intellectual property theft types of attacks. Getting in, stealing stuff, okay? And again, there may be a theft portion to it, sell it to the highest bidder, or there may be we want this, we want this intellectual property because we need to know how the missile systems are set up or how the airplanes are built, that type of thing, okay? And then the final one right now is hacktivists. We're here to prove a point. We're anonymous, and we're going to bring you down. Okay, we're going to prevent anyone from being able to do business to you. Okay, all of them have monetary value, and there's a lot of money being lost by these attacks every single day. Okay, billions and billions of dollars. Think about yourselves. If you have a commerce website, and if your website goes down for a day, what's that going to cost your company? A huge amount of money. And it can be prevented.
So this database of all the vulnerabilities sounds like quite a valuable database to have.
Yes.
One that
and it's
prime
publicly
target
available.
hacked.
It's publicly available. Anyone can look at it. Okay. These are the publicly announced ones. There's probably a lot more out there that aren't out there.
Oh.
And if you ever hear the word zero-day vulnerability, okay, what that zero-day vulnerability refers to is it's a vulnerability that is not known generally in the public by anybody so that they can protect themselves against it. Okay? Zero-day vulnerabilities usually extend from the point where somebody finds it, usually a hacker, it gets exploited, gets reported, the company fixes the bug, and then the patch goes out, and the patch gets applied. At that point, it's not a zero-day vulnerability anymore. Once patches are available, it's not zero-day. Now, just because the patch is available doesn't mean it's applied. The biggest attack that ever happened against all computers was done against a non-zero-day vulnerability. It was configured. Microsoft had patches for this thing out 6 months before the attacks happened. Why were they successful? People didn't patch their systems. So, in that sense, answering your question, what's more safe, more modern, or less modern? The hope is the systems are safer that are newer because people are fixing things. Okay? That's not always the case. Unfortunately, as we found out with some of the Oracle things, they fixed one vulnerability and they introduced 3 others.
Yeah, but they're adding features, right? Those features are what.
And it's not just features. It's unintended consequences. They don't have developers that know their code well enough to say, if I change a line here, something else is going to pop up over here. It's something that you really, when you're working on this stuff, if you design it properly, you won't have those problems. But if you've got spaghetti code that you don't have developers that know this stuff because they left 5 years ago to go to work for somebody else. If I make a change here, yeah, it's more secure here, but what else did I do?
Do they do anything on the cloud stuff, like if you're deploying to say Amazon or Google or whatnot? Do they maintain vulnerabilities?
They will tend to maintain it, but again, it depends upon what your service level agreement with them is.
No, but this site, do they have a list of the vulnerabilities of say Amazon?
I don't know. That might be interesting to find out. If somebody, I'll give you that. It's media.org, I think is the site. If somebody wants to look for it. Maybe it's in, probably the easiest thing to do is to go to the uscert.gov site, and then they have a link that goes to the National Vulnerability Database. Okay, so let's talk about secure coding in Java. Does anybody see a problem here? Complexity is the #1 enemy of secure code and secure coding. Complexity.
Quantity does not make complexity.
What's that?
I said quantity does not make complexity.
That's true. A lot of those libraries are boxes that don't have any dependencies going out of them.
Right.
And no access.
And you're right, I don't have the dependencies here. But look at the layers that you've got to go through. That creates complexity. Do you understand when I make a swing app, what are the things it's going to touch before it gets through the Java virtual machine? How many developers really understand that?
Right, but I mean, I've done swing applications. I didn't use any regular expressions. I didn't do any logging. I didn't do any reflection. I didn't do any of the management API. I mean, a good portion of that was never utilized in my code.
Which is good. That's excellent. That's good. But in general, how common is that?
Any one app's only going to use 6 or so, any of those things. I mean, it could be crazy.
Yeah.
And down at the bottom we have collections. They don't have vulnerable collections. They don't go anywhere. They're not vulnerable to anything. They're pieces of memory.
Yeah. But how many people, in order to be able to do this, add in third-party charts, or even Oracle's charts?
I can think of a way actually where the quantity does lead to complexity, which is a lot of us, we get our jobs by being Java developers. And so, even though my history may be, for example, in web development, I may be asked in my next job to do something, for example, with the collections API, and I might not know the proper use of concurrent collections versus non-concurrent or whatever. And so I don't have a command in the libraries that I might have if there were only, 3 or 4 of them there.
Yeah. Like I say, this group's probably slightly different from your typical Java development team because you guys have a lot more years of experience at it. And one of the things I learned in one of the classes I took on software process was you either have to have a good, strict process or you have to have really, really experienced developers. If you don't have one, you've got to have the other. Okay, that's the only way that you can get projects to work and get projects done on time and products that work. One or the other. So pay me now, pay me later. Okay, we've all heard about the Java security features. I mean, it's been touted, you know, Sun and Oracle have been touting it. You look on Wikipedia, you'll see these same things repeated out there. This is what Java does for you. I'm not going to go through all of them, because I think you probably all pretty much know about them. Okay?
We can just read that while we're just a second.
Oops. Okay. Let you read through that.
Class inheritance. I thought class inheritance was the first major break in the security model, actually, but wasn't it?
Yeah, it was.
Class
it was probably the first hole in the dike. Yes.
I'm sorry to take it away.
But there were many others since then. Okay, but you can escape the sandbox, right? People do it all the time. In fact, that's one of the major ways that vulnerabilities work at the application level. Is they escape the sandbox,
Which is only relevant in the browser and the phone.
Yeah. Okay. You have to know what you're doing when you're doing object-oriented design. Okay. If you don't understand how to do that, which a lot of people don't, and are writing Java code, you'll end up with problems. You'll introduce, in most cases, design flaws, but in some cases, coding flaws as well. Okay. The access security model, you have to find a way to be able to prevent data leakage out of that. You know, it's not difficult to do, but you have to do it right. And we have to remember, with attackers, we have to defend everything. We as developers have to defend everything. All they have to do is find one weakness that they can exploit, and then they can maybe chain another weakness that they can exploit. And in that fashion, get a full takeover vulnerability. Okay. The grants can be temporarily overridden. You need to make sure that you put them back once you're done with it. Protection domains are per thread, and yet Java is multi-threaded. And what are the implications of that? If you're doing any JNI code, you just lost your strict type check. Are you reading something in from the JNI code that you expect to be type checked already? And you think it's going to be good? Or are you passing something to the JNI code that you think is the correct type, but the JNI code thinks it's something else?
Is the JNI code updating the data between the first time you tried to access it and the last time you tried to access it?
Yeah. Class inheritance is not always intuitive. In fact, in most cases, it's not very intuitive.
Can you give an example of that? What do you mean by that?
Yeah.
So again, I'm not a Java developer. I haven't gone through the Java classes and learned the class inheritance. I'm taking some of this information directly from one of my Java senior developers who now works for Amazon, unfortunately. His example, if I remember correctly on this, was that they had, I think what it was they had one class that was, and again, it's the naming convention that was causing the problems. They had one class that they were pulling out of a specific jar file to use. And on a different thread, they had a very, very similarly named class from a different jar file, and they tried to interchange these. And it didn't work. It was obviously the one developer wasn't talking to the other developer on what they were going to do with this stuff. And so you thought you were inheriting from this class, and no, you're inheriting from this other one here.
A couple more examples of that as well as that one. One would be some code is overridden in the child class, and the proper functioning of the class, of the set of the application depends upon that overriding not happening. So that's why a lot of times people say, hey, declare it final by default, only allowed to be non-final if you design it that way.
Right.
Another case is, especially with Spring and a lot of more recent frameworks, is where you have a lot of dynamic proxying, and where you take something like security, which is a horizontal kind of cross-cutting concern, and apply it through proxy. You may think that something is being proxied by a security advisor where it's actually not.
Yeah. And the declarations can be modified. I mean, that's that example. Because of that, by the way, believe it or not, Amazon themselves have said within their organization, Java is not allowed in the browser. That's their decision that they made. That's the recommendation of the Homeland Security Administration. Do not enable Java in your browser. That's going to make things difficult for us.
Well, it's only applets.
Right.
Yes, it is only applets. But how many businesses out there don't rely on applets and use applets?
I can't find it.
They got beat by all the other stuff, by Flash.
But again, if you turn it off, if you're told you have to turn Java off in the browser, a lot of applications that you use every day go away.
No.
Yes, they do for me.
What do you use that has a Java?
I can't run GoToMeeting.
Yeah.
Oh, I just said that to the
I
guy.
can't run GoToMeeting.
It's the only one out there. GoToMeeting has a Java.
Oh, okay.
But isn't that true of other things and not Java, like Flash? Doesn't Flash have its own vulnerabilities as well?
Yes. And in most cases, Flash and PDF, Adobe's on everyone's ship list just like Oracle is right now. Okay, those two entities account for right now probably 50% of the vulnerabilities being reported in the NDE are between Adobe and Oracle.
So I mean, if Amazon said, okay, now disable Flash everywhere,
They probably have.
Well, I will tell you that since I work there, there was a huge row about killing Reader, Adobe Reader,
Mhm.
because of its vulnerabilities, and they actually were using Chrome for a while to read PDFs. That was very cumbersome.
Yeah.
So I guess this style of application would fall under your design flaw category there, in terms of like, by virtue of the fact that these apps are designed to allow runtime code within a hosted environment. It's a feature, but
Right.
it's also a source of vulnerabilities.
Yep. And in most cases, the design flaws are not introduced when it's initially designed. The code is designed properly initially, but then what you get is you get application and feature creep that now says, oh, this design needs to account for this additional stuff we want it to do, and it can't, or it won't, or people don't even think about it. Say, oh yeah, sure, I can do that. We'll just add these few lines of code here.
There's also, the other thing, of course, to remember is just because you can't find them on the internet doesn't mean there aren't billion-dollar companies that are still using them internally.
Yes.
And of course, once it's enabled to use for instance, your timesheet app, then it's enabled for every site you visit on the internet.
Right. Okay, so what are the things we as coders can do? The number one thing that we can do is validate input. If you look at the OWASP top 10 vulnerabilities and the MITRE SANS top 25 coding errors, more than half of them are input validation errors, not doing it properly. Okay. How many of, by the way, are familiar with OWASP here? You all should be. There actually is, I believe, an OWASP chapter here in Seattle as well. I've been to a couple of their presentations. I think they'll hold it at thread hash just across the way here down the lake.
Comment on that. Of course, these days with Ajax and more of the code being pushed out to the client with JavaScript and things like that, it's no longer input validation that you really have to worry about. I mean, you're shipping parts of your application to the browser, and that's basically under the control of the user. So input validation from a form submit read point of view is definitely an issue, but really the last couple of years with all the applications having more of a desktop style interface with back-end services and all kinds of other stuff, this is just way it's a much bigger issue than just this.
Right, but one of the things we'll talk about later is that you can't rely on the client to validate the info for you. Okay? If you do, you will get into trouble.
Exactly.
Okay.
The more logic you have on the plan, the more tempting it
Yep.
is to just do the validation there.
Yes. Yeah.
And you want to do the validation there, but you also want to do it on service.
Yes, you do want to do the validation on the client, but the server shouldn't trust that the client actually did it properly, and it should revalidate.
Your testers can't type garbage into the UI and tell whether the server is protecting itself.
Yeah. I mean, our testers, one of the things I've got on my desktop is I've got a text file that has 1030 A's in one buffer, 2050 A's in another buffer, and what's the first thing I do is I just feed that stuff into input. Let's see what I'm going to break. Okay? With Java, you don't have to worry about that. You're not going to cause buffer overflows. But in C apps and in C++ apps, it's fun watching those things break. And you can look at the stack dump and look at, my pointer. My pointer address, 041, is it 41? Yeah, 41 I think is A, is an ASCII A. I see ASCII A's in that address. I know I have essentially got a CVSS 10 vulnerability. I just took over the machine. Because I can inject whatever pointer address I want and run whatever code I want. So it's good to have testers that think like attackers. We need to get developers to think like attackers too. We'll talk about that. Okay, anything that user controls, an attacker controls. Therefore, all data is evil until you've proven it otherwise. Check size before using, copying, or passing on, particularly if you're going back and forth in the JNI interface. Make sure that you're not overrunning buffers anywhere. Okay? Java protects you from a lot of it, but not all of it. Blacklist versus whitelist. Are people familiar with that concept? Blacklists essentially say, if it contains this kind of stuff, get rid of it. Or convert it. Okay? The problem with it, if it contains this kind of stuff, can you list all of that kind of stuff in all of its various encodings? You can't. Whitelist is much better. It's more difficult to do because you've got to get the owner of the program to say, what are all the possible valid answers? Or what are all the possible valid inputs here? And then you have to make sure that you test against those valid inputs. It's more secure, it's more difficult to do. If you can do whitelisting, do whitelisting. Proper encoding. Make sure you know what coding system you're in. Okay? What are your characters coming in as? What should they be? What do you need to convert them to? And convert them back to use them. And don't forget files. We'll talk about file fuzzing. Microsoft, when they were first doing their security push, used file fuzzing, and I think they said that about 75% of all of the vulnerabilities they found in Office, they found with file fuzzing. Input validation on files.
What are you saying, file?
File fuzzing. We'll talk about that later when we get to the testing. I'll actually have resources that you can look at to find these applications that do that. Okay. And as we talked about, if you're the server, don't trust the client to do the validation. You have to, even if you know that it's done, you've got to do it yourself. Because you don't know who that client is. You may think it's your client that you wrote out there. It may not be. Okay. If we do this, we will take care of the two biggest of the OWASP top 10 bugs: cross-site scripting and SQL injection. If we do input validation.
How is integer overflow used for Raisted?
So integer overflow, I guess I'm actually amazed that integer overflow is going to still happen, because that means people aren't unit testing the way that they should be. They're not doing boundary tests on what they're inputting and outputting. Integer overflow is essentially it can be anything from and again, I don't think Java has this problem, but in C and C++ code you can define whether you've got an unsigned integer and is it 16, 32 or 64-bit. We actually have a lot of problems right now converting some of our 32-bit programs to 64, exactly because of the problems with signed and unsigned integers. We had, and again, these are C and C++, not Java apps. Although there are a few Java apps that we are having problems as well, going from the 32-bit to the 64-bit world. But again, essentially, if you think you're treating the number as an unsigned integer and you're getting a signed integer instead, your logic may be different. Okay, or you could even overrun it. If you subtract. In particular, the integer overflow, underflow happens when you take a really large number and subtract it from another really large number, but not really big enough, and you overflow the buffer. Because
no, I understand you can have bugs, like you can have bugs with time, like crazy things that happen with time. But then, are they like security vulnerability, or just that your app crashes? Or
if your app crashes, and it crashes in a certain way, yes, it is a security vulnerability. Every single time that you have an app crash,
like a core dump.
A core dump of any kind, yes. If you have one of those, first thing you think of is, can this be exploited? And that's why I have the buffers of A's, because I can tell real easily. If I put in this value in this field, and I end up with the memory pointer for my next location, all A's, I know I just took over the machine. Okay, that's a vulnerability that has to be fixed. Essentially that's a CVSS attempt. Okay. If it doesn't do that, then you probably then you have a regular crash. But regular crashes aren't good either.
If I put a $4 billion order into Amazon, do you think that's a security vulnerability?
No, I mean that's a different thing. That's you have a bug, right? That's
if I buy $4 billion worth of product.
Yeah, but it's not going to be reported at that site that have a security.
Yeah. So, I mean, there's business logic problems as well. I mean, a lot of your case would hopefully be handled in the business logic.
Yes.
Not necessarily in the code.
They're going to say it's not.
Got a lot of material to go through, so I'm going to speed up here a little bit. Secure coding principle number 2: compile with the strictest compiler. Check. Yes, I know Java is just-in-time compiling. Okay, I've been told that any number of times, including by the senior developer, who finally I beat about the head and body enough to show him that no, this really does matter. Okay? If I fix all the warnings in there, then it doesn't matter how it's compiled on my user's machine. It's going to be secure because I made it secure. I fixed all the problems. Okay? Now, there are cases you may not be able to fix. That's fine, as long as you understand what those cases are and why you're doing this.
Actually, if they've damaged the Java on their machine, they're running my code and it's perfect, then they've introduced security through the JIT. Security problems through the JIT.
Yeah. And whose name is on that? And who are they going to come back on?
Yes, but I can't keep the Java that's been installed pristine. My jar gets downloaded through WebStar or something like that, and I'm running, and my code is being jitted by the Java that's there. If that Java has been compromised, there's nothing in my code I can do about it.
Right, but at least it won't be in your code.
Right.
Yeah. And that's really what we're talking about is keeping not only your customers but yourself out of the headlines as well. You've done what you can. Okay. There are static code analysis tools, and they're built into most Java IDEs. I know Eclipse and IDEA both have static code analysis tools. Use them. They'll point out problems. Compilers are really great. Don't ignore them. They've gotten better over time. And unfortunately, they've also gotten better at being able to silence these warnings. Don't. Okay, least privilege. Most vulnerabilities occur in non-security related code. You're not going to have very many vulnerabilities in SSL or in SSH. Where you're going to have the vulnerability is I'm taking this number, adding it to another number, and printing the result out. Or I'm taking the user input and I'm just passing it right straight through to the business logic. Okay, that's not security related code. Okay? It may be encrypted, it may be hashed, it may have data integrity, but I'm passing it right on through. Okay? So, if you run with the least possible privilege, if and when you do have a problem, at least you won't be doing it at root level or system level. If you do have to run elevated, separate it out, do it for the least amount of time possible, and then set the privilege, or the elevated privilege back down as quickly as possible. Okay. Minimizes the chance of escalation of privilege attacks. Use the available tools. Java does have a lot of good tools out there to be able to secure things. Understand what they provide for you and use them. Okay. They have the capabilities to allow you to use this privilege. Use the security manager. Use the exception handling system. There are vulnerabilities being found now where somebody takes over the system through the logging.
What?
Through the logging, yes. Through the logging functionality. You're calling logging, you're writing this out somewhere. How are you writing this out? Where are you writing this out? How much can it take?
That's why I never log anything in my code.
But you do have backwards, right? And write clean code. Number one, it's easier for you to debug later on when you're going to have to fix it, or when you're going to have to rewrite it. Again, static analysis and compiler warnings will help you do that. Deciding upon, and I know this is blasphemy in our shop, I'm sure it is in a lot of other shops, but use a structure. Define a structure and use it. And use a standard of some sort. Getting people to agree on it is a difficult thing. I agree with that. I know that. I've run into that. But it's amazing what happens when 5 years down the road they've got to go back into that module and go, hey, I understand this. I can read this. I know what it means. Okay. That's secure coding. That's the first half of things. What is a secure development lifecycle? How many companies here have a secure development lifecycle of any kind? Even a nascent one that's starting out? Nobody yet. That's worrisome. Okay, well, all right. We'll talk about what a secure development lifecycle is, and then maybe you can tell me yes, you're doing it. Okay. Secure development lifecycle is a process that helps you address the 50% of the vulnerabilities that are due to design flaws, so you don't introduce them to begin with, and also helps prevent the 50% that are due to coding flaws, because you have processes in place to catch these things. It's an outgrowth of the CMM that was developed by the Software Engineering Institute at Carnegie Mellon. Very, very heavy process in that thing. This is not what we're talking about here. SDL can be very lightweight, and we have a lightweight process at Attachmate. That's what we use. Microsoft, in their usual fashion, embraced and extended it, and they actually made a pretty darn good process for themselves that works really well in their shop. Okay. They have things like you can't check code in until it passes the security checks that look at code. There's automated checks, and then it has to go through a security review during a code review process, and then it can get checked in. Microsoft can do that. Most of us can't. It sets up best practices in every phase of the development and delivery process. So it's not just writing code. What do your testers do? What does your CM do? What is your process of maintaining it? What happens when somebody reports a vulnerability to you in your code? All of that is involved in the SDL process.
You know, this check-in business, you know, when you use like something like Git, where you check in whatever you want, but somebody has to pull it.
Yes.
So it's not so much you, it's more like who merges it at the end. Decides to apply what law, whatever
Right.
guarantees he wants.
That's a difficult process to be able to apply SDL to because there isn't ownership. There's not ownership.
The guy who does the merge is the owner.
You know, actually, the owner is the person who does the merge. So
Yeah.
it's essentially an outgrowth of Linus and his compatriots trying to figure out how to deal with 50 people trying to change code. You
Right.
can efficiently tell them to kindly go away as soon as possible.
Yeah, and unfortunately, to put an SDL process on top of something like that is extremely difficult. What it takes is it takes dedication from the people that are doing the merges.
Right, but that should be like one in a very core group that is very responsible for, just like the Linux guy is.
Right. But again, you know, it's up to them. It's up to them to decide how much of this they want to implement and how much they don't. And if their product suffers because of it,
There are costs associated with
Yeah.
some of this.
Oh, yeah.
Too, so.
yeah, there definitely is. Yeah. This is what Microsoft's Secure Development Lifecycle looks like. The blue portion is their standard software development lifecycle with all of its phases and milestones. The inner circle is their secure development lifecycle. You notice that it's all the way throughout the product development stages, including out to delivery. And it starts with best practices and learning. Okay? The number one step in SDL is awareness. I don't know any developer out there that is purposely not going to write good code. They're going to try to not write good code. They just may not necessarily know what the best way to write that good code is. And if you train them on it, they will do it. They will want to do it. Because it'll make life easier for them too. Unless, of course, you've got contractors from China. I don't know. Then you've got to be wary. We do annual training. We actually started out with semi-annual training when we first started out. And it was unfortunately, it was a voluntary for us. Given my brothers, if I did it over again, it would be mandatory for every developer. Because, of course, there are some that won't come to this and didn't learn their lessons. And now they're having to learn them the hard way. And I would prevent that. You know, making it mandatory does help. Bill Gates made it mandatory. He said everyone that's going to work at Microsoft is going to be going through these classes, and if you don't do it our way, you're done. Again, he could do that. You notice they also didn't ship for 3 years. Okay? They shipped service packs on XP for 3 years before finally XP SP2, I think, was the first truly, well, it wasn't the first system totally developed under SDL. It was the first one that had implemented SDL at the coding and further phases. So they had the education, they had the coding and the further phases. Windows 7 is the first a system they had where SDL was throughout the life cycle. And you can see a big difference between Windows 7 and XP.
What happened to Vista?
Yeah.
Was that just their
Vista, the problem with Vista was Vista sort of got caught in between. I mean, they were starting to develop Vista as they were developing the SDL in general. And so they moved resources back. Essentially, they moved the whole Vista team back on XP to fix things. Then they put them back on Vista, and they hadn't done all of the training on development, on the design side, on the design and architecture side yet. They finally did that for Windows 7. So it was an in-between. It was never accepted. It was more secure than XP at the design level, but still not at the level that Windows 7 is. Okay. One of the things about the training is not every developer needs to be a security expert. They won't be. It is difficult. You have to have a certain mindset to be able to think about this. But you should be able to find in every development organization a group of 1 or 2 developers in every team that can be the subject matter experts. And they will be the ambassadors, they will be the people that go out and evangelize on this and push it. I was lucky. I was able to find at least 1 or 2 people in every team. In some cases it was a tester, in some cases it was a developer, in one case it was a product manager. Okay? It doesn't matter. It actually, what worked out better for us, because we didn't have any high-level management people in that organization that did this. This was all done grassroots for us at Attachmate. It was from development on up that we did this. Made it difficult to get resources. Okay. At the requirements phase, you have to define who's the product being targeted to. What regulations apply? Am I going to be handling credit cards? PCI DSS. Am I going to be handling health data? HIPAA high tech. Is this for the government? Okay, we've got FIPS, we've got common criteria, we've got all sorts of acronyms out there that we have to worry about. Financial. You have to know who you're designing this to, because based on that, you will make design decisions to say, I need to have this in there so that I can manage to pass the PCI DSS audits when this stuff's run. What quality assurance measures do I need to apply? Do we have to do common criteria? In Europe in particular, they're starting to look at requiring software vendors to have ISO 27001 or 2 or 9 certificates. Okay. The thing I don't like about those, the same sort of thing as with common criteria, the same thing was with some of the FIPS stuff. You define a process, you document the process, you run the process, you look at the process and improve it, and you start all over again. It doesn't say the process was good. It doesn't say it was a quality process. It's a process. It's a defined process. We follow that process. Is that a good thing? Maybe, maybe not. And will it produce good quality? Maybe, maybe not. Hopefully in the phase where you come back and improve things will get better. But it's quite possible the first couple iterations, and I think that's what happened with Vista, was the first couple iterations, they really weren't doing a good quality process. Okay. What security features do you require? Do I need to keep things confidential? Okay, I'm going to have to do encryption. Okay. Secure authentication. So I know who it is that's doing this. Do I have to have integrity? Does it matter whether somebody's entered $4 million or $4? Okay. You need it hashing and digital signatures. Accessibility. Does it have to be fail-safe? Is this a server that if it goes down, my company loses millions a day? You need to make sure that in that case that you've got fail-safe, you've got hardening, you've got throttling. Okay? This is the main reason DDoS attacks can occur. There usually isn't throttling in a lot of cases. Who would have ever thought that we needed to have DNS resolvers on our desktop TV boxes? So that they could run a DDoS attack against an entity. There are unsecured, in case you haven't heard this, the last internet attack that happened because there were unsecured DNS resolvers that would essentially not look at who sent them this request and pass it on directly to the DNS server to reply. And the DNS servers replied with spoofed addresses, replied back to the servers they were trying to DDoS. And they succeeded in bringing them down. Okay. If you implement throttling, you won't have that. Because you'll be looking at, okay, first of all, is this from a domain I recognize and I won't even talk to these people? Why would I pass this on? And second of all, limit it to, if I start seeing a lot of traffic from one particular set of IP addresses, okay, shut it off. Or limit it to, throttle it down to 1 a second, or 1 every 10 seconds. You'll be amazed how quickly the attackers go away when it starts costing them money to do this. Architecture design. First thing you need to do is look at the attack surface. Define what is the attack surface. What all interfaces are you using? What all protocols are you using? What ports have you got open? What ports are open by default? What scripting do I allow? Okay. The more of these things you have, the larger the attack surface is. You want to minimize that attack surface by default to whatever the minimum is that you can put out there and have the product functional. And then if you need to increase the attack surface on it because you need to run some sort of scripting that you don't need to do by default, enable that later. But don't have it on by default. I keep having this argument, and I keep losing this argument with product managers. But I want it to run right out of the box. That's great, but you want it secure? This is a secure server. Do you want it secure? No, I want it to run out of the box. Pick one. Okay? In some cases, well, in almost all cases, security costs something. It's either going to cost money, it's going to cost performance, it's going to cost pain in configuring it. Okay? Users are getting to the point where they're starting to be willing to accept some of the pain to do this because they want to be more secure. Okay? You have to balance those two requirements. And in most cases, unfortunately, they are mutually exclusive. You can't have convenience and security at the same time. At least I haven't found anything that gives you that yet. I keep hoping. That's the holy grail. Once you've done the attack surface analysis, you need to look at what the threats are against those attack surfaces. And then Microsoft, well, this actually didn't come from the Microsoft team. They actually borrowed it from, and I don't remember what the entity was that came up with this. The stride defines the threats. What are the threats out there? So there's spoofing. I can pretend to be somebody I'm not. There's tampering. I can modify either the data stream or I can modify the binary or files. Repudiation. I can do something and say, no, I didn't do it. There's no proof that I did it. Information disclosure. I can read the data stream. I can read the file because it's wide open, or I can read the Ethernet coming across because it hasn't been encrypted. Denial of service. I can prevent you from using this thing, or I can prevent you from doing a specific portion. And escalation of privilege. I started out as a user, but I was able to escalate up to root. Now I've taken over the system to do whatever I want. Okay. Those are the threats. Then what you will do is look at each interface or each feature or each of the things that you looked at the attack surface analysis and go, how likely is this? This is the threat. We define all the threats and say, okay, my threat is going to be I can read the FTP traffic going across the net because it's in the clear. Okay, that's the threat. Okay, how likely is it? Well, do I need a sniffer on the LAN? Do I actually have to be on the box itself? Okay, what does this affect? It only affects the users that are doing FTP. It doesn't affect everyone in the system. Okay, so dread allows you to determine the priorities of mitigating these things. So you'll do a dread analysis, and essentially, in most cases, these aren't highly numeric. They're high, medium, and low. And then based on what the cumulative score is, you decide this is the threshold that we're going to mitigate at. You go through and you look at what's the damage potential. Okay? Do I lose my company's crown jewels, or is this just something that somebody, prevents one user from doing something? How easy is it to reproduce? Notice these look very similar to the CBSS scores I was talking about. They are very similar to it. You can actually do a CBSS on the threats in most cases. How easily can I reproduce this? Can a script team do this? Exploitability. What is it that I have to do? Always get these confused. Exploitability is one area. Okay. Exploitability is, do I have to be on the network? Or can I do it from the internet? Or do I have to be on a machine and keyboard? Okay. How exploitable is this? Affected users, how many users does it affect? Everyone, one? And how easy is it to discover? If I'm running an FTP server in the clear, that's really easy to discover if I've got a sniffer running. It's obvious. Yeah, there's clear traffic going across. I know what FTP traffic looks like. I can sniff for password. And then finally, I know a lot of people are doing test-driven development. Look at misuse cases instead of use cases. Okay? Everyone writes their functionality for use cases, so you know that's going to work. Okay? That's what you're trying to do. This is the function that you're going to write, and this is your use case, and it's going to work. Think about misuse cases. What happens if somebody puts this in there instead of the other one? I've very, very often nearly come to blows with the developer who said, well, only a tester would enter that. In that field. Said, no, an attacker will too. And he's going to be a lot more serious than if I do. Because I'm reporting it to you, you can fix this. And if an attacker does this to you, you're not going to be able to fix it. In fact, you probably won't be working here. So I don't, if you ever hear that, or if you're a developer, never say that to a tester, because that's backwards. Okay, so here are the threat mitigation methods for each one of those threats. So for spoofing, you do authentication. For tampering, you have to do data integrity of some sort, integrity checking. Repudiation, you do non-repudiation, which normally means digital signatures. Information exposure, confidentiality, which is encryption. Denial of service is availability. You make sure that even usually it's things like throttling and things like that you implement. And elevation of privilege is you have to do authorization. Is this person authorized to do this particular action? Speeding up. Okay, secure development. It doesn't help if you don't have a secure repository that's locked down to only those developers and those users that need to have access to it. Okay? You don't need to have me as a tester having write access into that database or into that code repository. Okay? So you need to have access control methods on this. Yeah.
So do you have stats now that differentiate the security level of open source code versus
well, so what we do when we use open source code is we will bring it in-house and we will run static code analysis tools on it, in some cases dynamic code analysis tools on it. Then we will lock it in our repository, and if there are changes that need to be made, we bring the patches in, we code review them before we apply them. So if we're using open source stuff for our products, we actually bring it into our CSSS system.
So when you talk about securing the code repository, it's not so much that the code is out there, anybody can read it, the code is out there, anybody can change it.
Correct. Yes. Yeah. I mean, in most cases, allowing people to read code is not that bad unless you're worried about IP theft. Okay. And yes, there are some companies that will be worried about it, and they will set their code repository reads based on that.
But it certainly makes it easier for you to break the system if you know how the system's written, right?
Yes.
So if you know that this input field, when you put those A's, is going to do this, that, and the other.
But if you've done secure code development, and that's why, to me, bless us all that there are open source communities out there like OpenSSL. That has been well vetted, and as long as you get a version from them that they certify, that they say this is the hash on this thing, and you check the hash, and yes, there have been known cases where those have been changed. They've actually had people that broke in on their system and put out hacked versions of open source stuff. In particular, if you are doing cryptography, use open source. Please use open source. Don't invent your own, okay? Or pay big money to somebody like RSA who knows how to do this right, okay? To a company that you can trust, okay? Do not develop your own cryptography, ever, unless you're a cryptanalyst or a cryptographer and a perfect coder, and you do static analysis on it, and all the other things that are involved in SDL. In most cases, even if the open source isn't the best, if you do run it through static code analysis tools, you can make it better. And you can decide whether to give it back, depending upon what licensing that open source has. One of the things that we shouldn't ever do is rely on the fact that nobody knows our code to say it's secure. The most you can ever say as a security analyst when you don't know what the code's like, when you're doing black box testing, you can say, I have not found a vulnerability in this code. That's the best you can do. That doesn't say that the code is secure. It just means you just haven't found it. That doesn't mean somebody else will. So open source is better because of the fact that it has more of a chance to be vetted and to have these things taken out. You can also have really bad open source projects. Again, it's sort of where you have to look at what the trade-off is. I don't have the time to do this myself, but I do have the time to review this. Okay. Again, strict compiler settings, we talked about that already. Static code analysis, it's built into most of the IDEs use it. Our developers run it every single time before they check coding. They run a static analysis on that portion of the code that they changed. And if there's any warnings, they fix it. Same thing with the compiler. Static code analysis is really good at cleaning up legacy code. If you've got legacy code, or again, untrusted open source, it'll find all sorts of things and flag them for you. And things like, particular things like deprecated function use. Okay, testing and QA, yeah.
So, judging by your earlier comment, then we would never want to use Maven or Gradle with the repositories, that public repositories. We just go grab code from the public repository and use it without reviewing it first. Is that what you said?
Yes.
No, you can probably still use Maven and Gradle. You can still control what gets put into your local repository if you wanted to. You can upload it.
I definitely wouldn't. I certainly wouldn't grab it from there and use it directly.
Right.
Right,
Yeah.
that's what I meant. Never
But
do
you
that.
can still control. You can still use it as a process. You can still use the tools. You can still use CI tools, like Maven and Gradle. You just have to set it up so it doesn't just pull stuff from the internet whenever you want to.
Yeah, that's what I meant.
Yeah. Okay, fuzz testing. Fuzzing, the question came up earlier, what is fuzz testing? Fuzz testing is also known as random fault injection. Okay. Essentially, you're taking inputs, and there's two different ways of doing it. There's what's known as smart fuzzing, and there's dumb fuzzing. And dumb fuzzing is, I have an input, for instance, it's a file. And I'm going to take that file, and I'm going to twiddle every single bit in that file and read it in. Twiddle 1 bit at a time, or 2 bits at a time, whatever. At some point, every bit's been twiddled. Let's find what problems we have reading that file. and where do I crash? Smart fuzzing, you understand what the file structure is, or the protocol structure is. And what you're going to do is you're going to look at fuzzing around boundaries where you're reading in different things. If I know that this, in the protocol, this byte set tells me the length of the bytes coming in, that's one place I'm definitely going to fuzz that. Okay. There are tools available out there, quite good ones, that are freeware, that you can use to do this. And you can let it run automated. We actually have several teams that they have one machine that's doing nothing else but fuzzing full time. And yes, we have found bugs.
So what kind of vulnerabilities are you actually exploiting for the file?
In most cases with C and C++, it's buffer overflows, is what you'll find. With Java, I think it makes more sense to do protocol fuzzing than it does file fuzzing because of the protections that are built in. But again, if you're writing files out and then reading them into other programs, it's probably a good idea.
It's just about the data entry.
Yes. Yeah, it's any data entry point that you have, and just throw random data at it. Yeah, and see how it reacts to it.
It's an integrity check that you're doing.
Well, yes and no. I mean, it's partially an integrity check, and it's partially also a will I handle something that's not normal. Okay? Not so much that it's changed. It's not integral anymore, but it's not expected. It's input that I'm not expecting. How will I handle it? Dynamic testing, or DAS. I have not found any freeware tools out there that do it. It's really, really difficult to do. There are contractors out there that do these. In a lot of web apps, you almost have to go to dynamic analysis. Because in particular, if you're doing web apps that create JavaScript, right, this is not something that a static analysis tool will find, because it doesn't know what that JavaScript is going to look like. Okay? This is something that's dynamically done. It will test logic path dependencies, which you don't get with static analysis tools. Penetration testing. There's a lot of freeware tools out there. There's a lot of people that know how to do this. You have to be specialized to do it. Unless you're a large company, you probably can't afford to have pen testers in there, but it doesn't hurt to contract someone and say, here's the application, here's what it does, please pen test it for me. In most cases, what you can do is you give the pen testers the attack surface analysis you did. Say, here's the attack surface, and they'll go, okay, here's what we do. I haven't gotten to this point. I'm hoping that I can with Attachmate. I'm trying to convince the managers to allow us to provide our customers' security teams the attack surface analysis that we do. They're going to find out anyway. They start putting the app up themselves. They'll start looking for what ports are open, what protocols are running. They're going to do the analysis. So why don't we save them the money and the step and say, yes, you're a customer of ours, here. Let's save you some time. Okay, and then finally, OWASP. There's an automated tool that I have a reference to, I think, out here, that actually runs and tests for all of the 10 top vulnerabilities that OWASP has found. And it's actually a developer from SUSE that I think maintains that. Install and maintenance. All jars should be signed. And yes, I know there are problems with this. Actually, the latest version, 1.7 update 21, is now going to start flagging if you have any mixed jars where parts are signed and parts are not. And you'll actually get a security warning up by default now. I think with update, I think it was 11, they actually started flagging unsigned jars and not allowing them by default. This has to do with secure by default. That's one of the basic principles. I think Oracle's finally learning to do a little bit of that. And then, deliver or deploy in as secure a manner as possible. Make sure that once it's put out there that, you can check. Obviously, the best thing to do is to do code signing and a digital signature on it should be validated before every time it's run, but I doubt that there's very many systems out there that do that properly anyway. Then, when, not if, a vulnerability is reported, how are you going to handle it? You have to have a process for this. That's part of the SDL as well. The funny part is usually this is the instigator in starting an SDL process. It was for us. We had a vulnerability reported against one of our products. And we said, what do we do? So the first thing we defined was the incident response process. And we said, okay, how can we be less knee-jerk reactionary? And that's how the rest of this stuff fell into place. So we sort of built back from, the bad incident. I'm trying to save you guys the pain of this. Okay. All right. After hearing all of this, how many of you have an SDL? Still don't. Okay. Sort of. Maybe not my team, but okay. And actually having one team implement it first, or parts of it first, really works well. I mean, these are the things that I can tell you about what happened at Attachmate. It's been 4 years since we've been doing this. Okay? We actually started out when Michael Howard from Microsoft, who was one of the inventors of their process, came and gave us 3 days worth of classes. Talk about being exhausted at the end of this. Total brain dump from him. Okay? And that's what got us started in this, was getting the education first and changing the mindset. Okay? So the first thing you want to do is, what of these things do we already do? What's our code repository like? Do we do code reviews? Do we have the strict compiler settings? Do we sign our jars? Write down all the things. I actually have a spreadsheet that I created that has, I believe, we're up to 27 tasks or thereabouts in there. And I had every single one of the teams sit down and fill out that spreadsheet and say, we do this, we do this, we do this, we don't do this, we're planning on doing that. Every year we review it and we try to make sure that there's progress, that they've added 1 or 2 things. We started out by saying, of those 27 things, here's 11 of them. You need to do 7 of those within the next year. That was our goal. And the teams that made that goal got I think they got t-shirts and pizza lunch. Whoa. It was a low budget operation.
That's the part where roots up thing. Okay, so when you introduce 27 things that perhaps you are not doing on your software development cycle, that are going to impact the rate of your software development.
Yes.
How do you sell that to management who wants to get a product out and go every 2 weeks?
It was difficult. I will say at least our management wasn't against it. They weren't for it. And it took a while to convince them.
Well, it's why you work double time to get it,
Yeah.
do that and get it.
And I think in our sense anyway, and again, Attachmate WRQ is probably a slightly different type of shop than a lot of shops out there. I've been with the company 17 years. I'm the junior member on my team. Okay, most of the developers have been around longer than I have, so we have a lot of continuity. There are people that want to do the right thing and do things the right way. And yet they want to learn these new things. Security is the new buzzword. I need to learn security. Okay. It's probably a lot more difficult in a shop where you're going to be forced with really, really tight schedules where you can't fit something in. In a case like that, what I would recommend is rather than starting with, showing them a list of 27 things, is ask the teams what are the things they do with these things. Let them start out with 3 or 4 on that list already and add 1 more each release. And yes, it will take you longer to get there. One of the things you want to do, though, and this was very effective at Attachmate, is you let the teams decide which task makes the most sense for them to do. Because they know the code. They know what the code's like. And what's going to give them the most bang for the buck with the least amount of effort. Let them start with those. Let them get those successes under their belt. Celebrate those successes. And then each cycle you add a little bit more. and eventually you'll get there. Microsoft, like I say, they didn't ship a product for 3 years. And they still weren't at the top level of the development of the SDL cycle. It took them at least 5 more years to get to the point where the whole process was in place. And they're still working on it, yeah.
I also know another technique I've seen work in convincing management, and that's have somebody actually demonstrate an attack on the system. We had a tech support guy at a former company I worked at. Guy in tech support showed how to download social security numbers out of the database using SQL injection. That got immediate response.
Yeah. I mean, usually that's what will drive this thing, is, oh, you had a finding. Okay.
That's motivation by just getting a side job. So
What's that?
that's motivating the company by getting a side job, talking to some folks in Eastern Europe or something, hedging your bets employment-wise.
Yeah. Be very careful with that, because there have been people fired that did that.
Oh, I'm sure.
There's an Intel engineer who got prosecuted.
Yes.
I'm sure people.
Solidarity helps. If they have to fire
that's-
everybody, they generally will.
Yeah, they'll usually back down.
What happened in our case was the tech support guy notified developers, and then the developers were basically buffered that just said, hey, we found out about this from tech support, and they got attention.
Well, where I was just working at agency, they actually have security scans that they do.
Yes.
On a regular basis. Our problem is always being reactionary. Oh, we found it, here's your list, and it's like, top thing you gotta do, drop everything else.
Right.
And really disruptive to the development cycle.
Yeah.
Actually, to that point, I'd like to point out that some of these things belong upstream from the actual software development writing code part, right? I mean, design stuff, things like that.
Well, the education first. I mean, that's got to be the first thing.
So
Yes.
it's not just like the devs that need to be involved in this. It's sort of company-wide, right?
Yeah, but it is full development staff. So not just the coders, but it's testers, it's CM, it's project managers, product managers, marketing. I've got to say, I really feel good this year, because I actually finally had a product marketing person come tell me this sold product. We went to talk to a customer, we told them about our secure development process, and we showed them the documents on our secure development process, and they said, yea, verily, we will pay you money, therefore. Okay. Yes, it took 5 years before I finally got, I actually still have one product manager I'm fighting with who won't accept this thing. Says, no, my product doesn't need it. It runs on a Unisys system. Because he is the one that brought me that chart. Okay. It is a multi-year process, and it is a lifestyle change, so you do have to celebrate it. Okay. Secure coding is important, but it's not enough. That's only a small part of it. Okay, remember, only half the bugs are due to coding errors. Preventing design flaws is equally as important. The SDL process helps to make both of these a part of everyday life that you fix. It provides you a path that you can take that, if you follow, will clean things up. Okay? It's not a panacea, it's not a silver bullet, it's a lot of work, it's a lot of time, and you'll eventually get there if you start on it. If you don't start on it, you never will. And be aware that even with the best SDL process in the world, Microsoft still handles 40 to 50 vulnerability calls a day. Most of them on other apps that are running on their systems. So you won't be perfect. You can't be perfect. Any code, what's the statement? Any code that is being run in the world today has a flaw in it. The only code that is flawless is stuff that isn't being used. Okay? All of these will help protect the customer's investment, it'll help protect your company's investment, and hopefully they'll make them happy and they'll give you lots of money. Okay, I will provide this slide deck to Nimrek. You can go ahead and anybody that wants it can get it from you.
I'll just post it on the mailing list.
Okay, good. So feel free to grab the slides. These are links, so you can find the fuzzers that you want. Yes, Peach Fuzz is a product. The guy that does this is here from Seattle. He's just down the lake. This is the first open source one. Circ Fuzzer is more of a dumb fuzzer, but it is very effective and it's pretty easy to use. Both of these can be automated inside any kind of automation system. They're easy to use. They have a command line interface. The Peach Fuzzer has the advantage that it can take a Wireshark trace and allow you to grab packets out of that and define smartly what portion of the packet is what, so that you can fuzz intelligently on protocols. It doesn't do SSL or SSH yet. They're working on that. But it does do the most common protocols out there.
I have a question about repudiation. Could you define that a better?
Yeah, so, I mean, repudiation is a tough concept to understand. But essentially, what repudiation is if I'm able to find a way to do something on your system. For instance, I made a transaction and withdrew $5,000 out of this account, but you can't prove that I did it because you don't have any controls in place to prove that it was me that did this. How would that happen? The easiest way to do this is a cross-site request forgery. I don't know if you're familiar with that attack.
What is the issue though? Not so much that I can't prove that you did it, but I can't prove that you weren't impersonating. Is that like impersonation of somebody?
No, it's not necessarily impersonation of somebody, because again, it could be simply because you don't have enough controls in place. If I can find a way within your application, within your web application, to step around the authentication portion, so you never authenticated me, but I've got access to the account, I can now do whatever I want. Okay, and I can tell you, no, I didn't do that. I want that money put back into my account because you don't have proof of it. Usually for repudiation, what you want to do is you want to audit transactions and you want to digitally sign the transaction with the time and date that it was done and by whom. Okay, that's usually how you prevent or the repudiation portion. So you've non-repudiated it and said, no, see, here's a record that shows at this and this time you did this.
So is repudiation defense against the non-automated?
I mean, it sounds like you're saying somebody was able to get around something rather than they call you up and say, put some money back in.
Yes.
That's what you're
Yes. Okay. Yeah.
I think there's a good example just from kind of like real life outside of computer security, but like if somebody finds my fingerprints on the gun that was used to commit a crime, or somebody videotapes me holding up a store, then it's a lot harder for me to say that I didn't do it. Right? So that's the concern.
Right, I was thinking that this was within the confines of the application, and this is out of band from the application.
Yeah. It can be in-band too. I mean, if you don't do audits, if you're not doing transaction auditing, you've got a problem with repudiation. Because somebody could call up and say, no, I didn't do that. Prove that I did.
Your name's on the check.
Yeah, a classic case on this thing was one of the first fingerprint scanners that was available out there for laptops. You put your fingerprint on it. It was a plate. It wasn't the new roller type of things. It's a plate. So the guy logged in the first time, logged out, and went, logged him in. He didn't put his fingerprint on there. The oils from his finger were still there. Oops. Okay, any other questions? A lot of material. Let's see if you're right.
So just a comment. I mean, I'd just like to point out that, to your earlier comment about any code that's running out there really is a vulnerability. Despite the secure development lifecycle and all that stuff, Stuxnet still caused a lot of damage.
Yes, but hopefully you minimize it. I mean, the process hopefully will allow you to minimize the chances of it. But don't ever think there's no such thing. Well, other than that one Microsoft system. They locked in the room.
Unfortunately, a lot of it is making your competitor a more valuable target than you are, and waiting for the wolves to eat his flock at the straight door.
It's the club effect, right? If you've got two cars, one of them that has a club on it, which one's the thief going to take? The one without the club because it saves him 30 seconds? Unless, of course, it's a Lamborghini versus a Yugo. But yeah, essentially, you don't have to run faster than the bear. You just have to run faster than the person that's with you. All right. Well, thank you.
All right, thank you.